Hi, welcome to UTA's Department of Electrical Engineering video tutorial series. Our first series of videos will cover soldering. UTA EE students can access all the equipment and soldering practice kits in this video for free. If you would like to follow along with this series, you will need a soldering iron, a sponge, some perf board, some resistors, some 6337 or 6040 rosin core leaded solder, ESD safe tweezers, wire cutters, needle nose pliers, and a small fan. This video will cover basic soldering techniques, and you will practice soldering a few resistors to a perf board. This completed board will be used in our next video on how to desolder. Let's start by going over a few key items on the solder's label. The SN63 on my label tells me that this solder has 63% tin and the PB37 is 37% lead. This alloy has the lowest melting temperature of all the solders at 361 degrees Fahrenheit or 183 Celsius. The diameter of my solder is 31 thousandths of an inch or 31 mils. This can be measured with a caliper if you don't have a label. The rule of thumb on the size of the solder is if you're soldering a very small part, use a small diameter solder. And if you're soldering a large part, use a large diameter solder. 31 mils is a good diameter for most resistor-like components. The 44 rosin core is critical for soldering electronics. This rosin core is called flux. When the solder is heated, the flux core flows onto the pad of the PCB and the lead of the component and dissolves any oxidized metal. This allows the solder and the pad and lead to bond at a molecular level. Oxidation can render a soldering iron useless if left on and exposed to air. In order to prevent the early demise of your soldering iron tip, we will need to tin the tip. Tin, being the major component of the solder, implies putting solder directly on the tip of the iron. This is only to protect the iron tip, never to actually solder. The flux in the solder will clean any oxidation from the iron tip, and the solder itself will prevent oxygen from coming in contact with the iron tip. The smoke is the flux boiling out of the solder. Flux can irritate your nose, throat, and lungs. Please use a small fan to blow the flux fumes away from you when you're soldering. Or better yet, use a fume extractor to really clean the air. Most soldering irons have a simple screw holding the tip on. The soldering irons here at UTA are a little different. Lesson number 1 is to always assume the soldering iron is hot. So here's a technique to change the soldering iron tip while it's still hot. Remove the sponge from the iron stand and use pliers to unscrew the collar. Place the hot collar in the metal bin of the iron stand. Use pliers to place the old tip in the tip holder built into the iron stand. Install the new tip and replace the collar. Hold all the hot pieces over the table so if you drop them, they don't land on your legs. Replace the sponge and you're ready to go. Look at these 4 different iron tips. You can see tip number 1 places all its heat in a small area and would take a long time to heat the pad and lead. Tip number 4 overhangs the pad area and could burn the PCB or cause the pad to lift off of the PCB. But number 2 and number 3 are suitable choices. Try to choose a tip that is around the size of the pad and you should be just fine. One particularly frustrating problem is trying to solder a PCB that is not secure. Use a vise to secure your PCB so you don't have to chase it around the table. We will need to set the iron temperature to 600 to 620 degrees Fahrenheit. If you're using a lead-free solder, which has a higher melting point, set the temperature to 700 degrees Fahrenheit. A solid LED indicates that the soldering iron is heating up. A blinking LED indicates that it has reached temperature. When the LED turns off, that means the soldering iron is cooling down. Go ahead and turn on the soldering iron to the correct temperature and dampen the sponge with water. There is no need to soak the sponge. Use distilled water if available in order to reduce buildup of minerals on the iron tip. Wipe the old solder off the iron tip onto the damp sponge, or you can invest in a brass sponge. It should look shiny. If it is not, it has probably become oxidized and will need to be changed. Tin the entire tip again and return the iron to its holder. When you hold the soldering iron, keep the side of your palm rested on the table to stabilize your hand. If your PCB is secured too high, use a stack of books or boxes to rest your palm on. In order to see better, I recommend using the Helping Hands magnifier. Use the ESD anti-static tweezers to bend the leads of the component about 1/4 an inch away from the body into a horseshoe shape. Bending at the component body can damage the component lead connection. Insert the component into the non-copper pad side of the perforated board, or perf board. Slightly bend the leads of the component on the copper pad side of the perf board so the component doesn't fall out when you flip it over to solder. You will always solder with a clean iron tip. You will always wipe off any old solder onto the damp sponge. Place the end of the solder against the PCB pad and component lead. Gently place the tip of the soldering iron onto the solder pad and lead. The tiny amount of flowing solder and flux promotes wetting. Proper wetting allows heat to flow quickly from the iron to the joint. It kickstarts the heat transfer. Feed additional solder onto the part of the pad furthest away from the iron. This ensures the whole pad has reached the proper temperature. Add enough solder to fill the entire pad and create a volcano-like shape. Move the soldering iron up the component lead to remove the soldering iron. Let the molten solder solidify before moving the PCB. Solder the other component lead in the same manner. Tin the tip and return the iron to its holder. Use the wire cutters to trim the leads of the component just above the solder joint. Do not cut into the solder joint. Placing the tip of your finger at the top of the lead before you cut will prevent it from flying into your eyes and makes for easy cleanup. Go ahead and add 5 or 6 more resistors to get the fill down. When you're done, stop by the lab and we'll look at your work under the microscope. Remember to save your board for the next video where we'll practice desoldering.